This is question number 8 from exercise 9.3, chapter Circle, class 9. In this question, it says that if the non-parallel sides of a trapezium are equal, prove that it is cyclic. So what we know as a property that if either pair of opposite angles, right, if sum of any pair of opposite angles of a quadrilateral is 180 degree, then the quadrilateral is cyclic. So first, it's given a trapezium. So let's make a trapezium. I'm making a trapezium here. Let's say these and these be the parallel sides of the trapezium. And let's say this be the non-parallel sides. And let's say if I make this as ABCD. Now we have this trapezium and we name it as ABCD. And it's these are the two parallel sides as you can see in the figure, and the non-parallel sides are AD and BC over here. So what we are going to prove that either one pair, let's say if I target to prove this angle plus this angle as 180 degree. For that, there is a construction. And in this construction, we'll be drawing altitude from A as well as B. So this is, say, one of the altitude. Let me draw the other altitudes. Let's say from B, I'm drawing another altitude. Now, I name this as, say, AM and, say, BN as the altitudes drawn. In the first part, I'm going to prove these two triangle congruent. That is, the triangle here I'm going to prove congruent is one is this, another is this. I'm going to prove these two triangle congruent. This is the first part of the working. So we'll be writing. We have triangle that is in triangle ADM, and the other triangle is BCM. Now, how can they be proved congruent? First, I can see that the side AD is equal to BC. These two sides, AD and BC, are equal, right? That's given. So I can write the reason here as given. Further, we know that these angles are 90 degree, right? Here, angle AMD is equal to angle BNC. That is each 90 degree. Now, also we know that the distance between two parallel sides, parallel lines are always equal. Like these two are parallel lines and their distance are this. So the distance between two parallel lines are equal. So we can say here that AM is equal to BN, and this is from the distance between parallel lines. So we can say the triangles are congruent. So we can say the triangle ADM is congruent to triangle BCN. Right, this is ADM and BCN. Now, once we prove these two triangle congruent, clearly it is by RHS, that is right angle hypotenuse side. So the triangles become congruent. Now, if these two triangles are congruent, I can say that the angles, that means we can write these two angles, say one is this, will be equal to this. That's from CPCT. So I'm writing here, we have angle D is equal to angle C. That's from CPCT, which is corresponding parts of congruent triangles. Now, what do you know that whenever two lines are parallel, as you can see here in this figure, we have this and this are parallel lines. So you can say this angle B, that is ABC, and angle C are co-interior angles. Right? Whenever we have two lines as parallel, the co-interior angles are supplementary. So here I can say these two angles, that is angle B, that whole of angle B, by that I mean to say angle ABC plus whole of angle C, clearly that is C only, is equal to 180 degree. And the reason is co-interior angle. This is from the reason co-interior angles. Now, from these two equations, say equation 1 and equation 2, what in case if I replace this, if I replace this angle C here, if I replace this angle C, right, we have this C, and here also you can see it is angle C. If I replace these two C angles, the C can be replaced with D, as you can see in the figure. So I'll write this is angle ABC plus, I'm replacing C with D, as C and D are equal. That is angle D is equal to 180 degree. So now what we have done here, we have proved one pair of opposite angles as supplementary. You can see in the figure. Now what I have proved here, we have proved this angle D plus angle B is equal to 180 degree. And as you know that if one pair of opposite angles are supplementary, as I have told you in the beginning, that the sum of opposite, if you prove that sum of opposite pairs of a quadrilateral is supplementary, then it becomes a cyclic quadrilateral. Therefore, ABCD is cyclic. Is cyclic. This is what we had to prove in this question.